In the previous video, George, KJ6VU, and I discussed the station controller components, how easy they are to customize, and the benefits they can offer your station. If you haven't seen that video yet, I'll leave a link in the description. Join us today as we discuss the software behind the hardware, how easy it is to learn and configure, along with the community support that's available. All right, and I'm back today with George, KJ6VU from Sierra Radio, and I am really excited to talk to you some more today about your about the Sierra Radio boards and how they work, and how everything just works together, and how easy it is to make these things get these things up and running. So, George, welcome.
Thanks, Mike. Appreciate it.
So we're going to dive in today. Let's just dive into Node-RED, and I think that's kind of really important to give people a foundation to how all these boards talk to each other. So why don't you start there? Let's talk about what Red is.
So a little bit of a history on Node-RED. Node-RED is a programming language. It's a graphical programming language. And of course, we all know programming languages like Pascal and C and Python, and depending on what area you're from. But Node-RED is a graphical programming language, which means that you have a graphical user interface. You pull objects out of a palette of objects and you stitch them together like a schematic diagram. And I'll show you what that looks like here in a little bit. The advantage of a graphical programming interface is that it's pretty easy to do. You don't have to learn a bunch of fancy syntax. You can just grab objects, stitch them together, and publish the program, which starts it up, and it's up and running. So Node-RED was originally developed for industrial automation purposes. It was put into the public domain, and so anybody can use Node-RED. There's no cost, there's no license fee. The other thing that's nice about it is if I create a Node-RED flow, which is what you call a program in Node-RED lingo, if I create a Node-RED flow, it's all in printable text, and I can send you a copy of that program, and you could load it on your computer or append it to a program you already have, and it's really easy to share programs around. So it's a very simple environment to use. The other thing that's really good about Node-RED is it's built around the idea of having a web user interface as its primary interface, both for developing the programs and also for interacting with Node-RED. So you use a web browser to actually see the dashboard and the control panels and all that. And you also use your web browser for the development of the software itself. So let's go ahead. Go ahead.
So I was just going to ask you, why Node-RED versus C or Pascal or something else?
Yeah, great question. I think it just depends on how familiar you are with programming languages. So for example, if you are very familiar with Python or C or any other programming language, and you can create a graphical user interface and then have all the logic behind it in the language, then you don't need to use Node-RED. So for the station controller, you could write your own front end in any language you want. You can use, a Python and whatever graphical library you like, and you could build it because we publish all the specs about how to talk to the modules. But for most people, a lot of people aren't really programmers. They don't want to learn that. They just want to use something off the shelf, but they want to be able to modify it. And if you're not learning a regular language, like a text-based language, Node-RED is easier to modify someone else's code and to make some fairly significant modifications without a lot of difficulty. So it's easier for most people to create things in a flow-based programming language. By the way, the only reason, why wouldn't you say, well, why doesn't everybody just use these languages? And the reason is that when you're building really, really big systems of software, graphical programming is really inconvenient. So what I mean by that is, like, if you're writing the equivalent of 20, 30, 40, 50,000 lines of code, doing the equivalent thing in a graphical programming language could be very cumbersome to manage. And so there's kind of a limit of what's practical. But for any application that I've ever seen in ham radio, it's got way more capacity than we'll ever need.
Awesome. Okay, so you had something that you wanted to bring up on your screen.
Yeah, so let's go ahead and first of all, let's take a look at what the dashboard looks like for our system. So let me select this screen to start with. Let me know if you can see the web page. I'll assume that means no.
You're
Can you
good.
see the web page, Mike?
Yeah, I can see it.
Okay, good. I wasn't sure. All right, let me pull it back up here. Okay, so what you're looking at here is a web page that's served up from a Raspberry Pi running the station controller's dashboard. Now, this particular station controller has 3 different modules plus a Raspberry Pi as the host. So it has a general purpose I/O module, it has a 4-port antenna control relay module, and a watt meter module. So the majority of what you're seeing on the screen are really on the GPIO module. So you'll see on the left-hand side where it says relays, there's relay 1 through 8 and on and off buttons, and the LED there says what the status is. So for example, at the very top, relay 1 is currently off because it's red. If I click on the green button to turn the relay on, then that would send the command to the module to turn the relay on. Or if I click the relay off button, it'll send the command to turn it off. There's 8 digital inputs that you can see next to it to the right. Then further to the right, there are 4 voltmeters that are currently showing from 0 to 20 volts, but the actual range on the station controller is 0 to 50. And then there's 2 more digital temperature sensors, sensor 1 and sensor 2. Those are not plugged in currently on the module, so there's no temperatures shown there. In the lower left-hand corner are 4 buttons for the coax relay, where if you select a particular coax relay, it'll send the command, it'll switch the relay, and then send a command back to update the screen. One idea that's really, really important in the station controller is to know that you have positive control on the module, and it's not a fire and forget. So whenever you actuate something like the relay, what's happening is the Node-RED dashboard is sending the command to the module. The module decodes the command, it does the task like flip a relay. It then packages up a response with the status of that module, including the new state of the relay, sends it back to the dashboard. The dashboard interprets that, and then it updates the display. So what you'll see is when you're actually using the dashboard, you'll press a button and then maybe a second later you'll see the LED change state. And the reason is because it's not changing state because you pressed the button. It's changing state because the module said that the state of the relay is now changed and you're getting that updated information. So you know that it's actually working. And then towards the right, you'll see RF watt meters. Each watt meter control module supports 2 directional couplers, which means that I can have forward and reflected RF power on 2 different ports. They can both be HF, they could be HF and VHF, they could both be VHF. You just plug in whichever module or controller you want into the module, and then it'll use the right settings for that one. So this is what a general control panel would look like. If you had, let's say, 2 coax switches, not just one, you would have those 4 buttons in the lower left-hand corner replicated somewhere on the display here, and you'd have 2 sets of those. So it's really quite simple to do. So the dashboard, this sort of graphical user interface is super easy to do in Node-RED. Some things in Node-RED are easier than other things, but creating a dashboard like this is really, really simple. So let's take a look at what it actually looks like under the hood. So I'm gonna switch us over to uh, the second screen that I've got, which will show us what the source looks like. Okay, so can you see the flow diagram, Mike?
No, not yet. Okay, there it is.
Okay, so what you're looking at here is, again, through a web browser, you're looking at the development environment for Node-RED. So what you see is off on the left-hand side, there's a palette of all these little rectangular objects. These are the functions that you use to create your program. So you can think about it, if you're a regular, let's say like C programmer, you would have a line of code that says something, A equals B plus C. Well, in Node-RED, you would have a module that performs that function. And normally in language-based programming, you execute a line of code, then you execute the next one, then the next one, then the next one. Here, the reason they call it a flow is that the code is executed left to right from one block to the next, and you pass parameters to the next block, depending on what you're trying to do. One of the huge advantages to Node-RED over using a regular programming language is built-in concurrency. So what that means is that when the code is running, you can have multiple things happening at the same time, and you don't really have to program that schedule to do that. So that's one of the real advantages of this kind of a programming language for device automation. In fact, that's why they built it that way. Again, they built it for industrial control applications where you're doing a bunch of things at the same time, and so you want that to be easy for the programmer to do. So let's take a look along the top, and you can see different tabs. Each one of these tabs is another part of the program. All of these tabs all together form the entire dashboard. And then in the middle, what you see is the actual program. So let's take a look at the GPIO module. There's two parts to the GPIO module program. The first part is when I press a button to turn relays on and off, what happens? The second part is when the sensor data is coming back to the dashboard from the control modules, that data needs to get parsed and then sent to individual gauges and LEDs and such for display. So we'll start with the simple case, which is the relay control. So you see here in the upper left-hand corner, there's a whole bunch of blue boxes. They say relay 1 on, relay 2 1 off, relay 2 on, relay 2 off. And then those are all wired into a little arrow that is kind of it's a connector to another part of the flow. So let's take a look at the first object here. So the relay 1 on object, I double click on that, and the panel slides in from the right-hand side. So these are all the parameters that you would set for that particular object. So you can put that object in a group, you can decide how big it is on the display, you can decide what the label is, and then eventually when you get down further, you'll see it, there's about 2/3 of the way down, it says when clicked, send the following. What this means is that I know that's a button. When I press that button in the dashboard, send some data to the next object in the flow. So what you see there under payload, that string that says /0001 colon RY1 comma 1, etc., that's actually the control protocol that we defined for our system. What this says is slash means here comes a command, 00 is the main control PC, and then 01 is the device you're talking to. So device 0 is talking to device 1, and the command is between the colons, and the command is for relay 1, comma 1. 1 means turn it on. It's that simple. So here, by the way, if you said, well, I want to write my own Python front end, all you need to know is that command, and you can write your own Python code to send that string out the serial port, and it'll do the same thing. This is how you do it in Node-RED. Now,
cool.
and where this connector goes, by the way, this little square with the arrow, that's just a shorthand to say that the data goes to the part of the program that sends the command out of UART, and it is that simple. The rest of this stuff that looks much more complicated is more complicated because this has to decode the packets coming back from the module. So what happens is I hit the button, it sends that little ASCII string that says RY1, comma 1 to device 1. Device 1 gets it, it decodes it, it says, oh, turn on relay 1, it does that. Then it packages up a response. That's called an update packet. That string then comes back to the Node-RED dashboard. And in that string, it looks like the relay command, but it's got more stuff. So it'll say update, it'll say what node it's coming from, or which module. So from module 1 to module 0. This is an update type of packet. And then there's a field that says what kind of device it is, a GPIO module. And because of that, then the code knows how to parse out the rest of the string. And what's in the rest of the string is the state of every relay, 8 of them, the state of every digital input, 4 of them, the voltage of the 4 voltmeters, and the 2 temperatures. And all that comes back as a ASCII delimited string from the module. And this flow here breaks that out into the various gauges on the far right. So if you look over on the far right-hand side of the flow, you'll see that for example, the far right, it ends up with a little LED icon. There's actually 12 of them, 8 of them called relay 1 through 8, and then 4 more that are called input 1 through input 4. Those are the little LEDs that you saw previously on the dashboard. Below that, you'll see other objects like a voltmeter. And the voltmeter is that the one that we used is that 180-degree, looks like an analog meter. Just by putting this object on the screen will instantiate that meter in my dashboard. And that's all there is to it. I mean, there's no weird library stuff you have to figure out. Everything before that is all how you parse the data out and split it up and send it to each of these objects. So one of the really cool things about Node-RED is, let's say this is your GPIO module, and then tomorrow you get a second GPIO module. In order to add a second GPIO module, what you need to do is take this flow as it sits right here. I can select the whole thing. I can then copy and paste it. So now you can see on the screen, there's a second copy of that flow. Now I have a second GPIO module, and it'll come up on the dashboard. The only thing that I have to do to modify this is to tell it what the particular address is. So when I go into this particular block, this one actually has some code in it. So for those of you who are line code oriented guys, you'll be happy to know that you can always add code in a block if you want to. Most of these blocks have no code in them. They're just prefixed functions. But you can have a block where you do have code. So what you'll see here, this is JavaScript, and in the JavaScript code, on the third line, it says header equals /0100. What this means is if this payload, if the payload or the command that's coming in is from device 1, that's me. If this is the second copy of my GPIO module, all I've got to do is go here and say, well, I'm going to make this device number 7. So I'll change this to a 7, hit the done button. That's it. I mean, I'm completely done, except maybe I want to change the layout of where things go on the page. But otherwise, that's it. That's all it takes to add a second module to your flow. So that really, really makes it simple. And when we want to deploy this, there's a big red button that says deploy. You click that button, it syntax checks everything, and everything looks good. It relaunches the web server with the new modified version of your flow. And that's kind of all there is to it. So as you can see here, there are a lot of different kinds of functions that you could put into your program. So you can manipulate data, you can do database stuff, you can parse information into and out of different formats, you can store data, retrieve data from disk, you can send an email, and there's tons of Node-RED object libraries out there that you can add to your system. So it's a big open source community. There's a lot of people who've written libraries of functions, so you can extend even your language with more and more libraries of these programming objects you see on the left-hand side.
So while this really is not that, this maybe on the surface looks complicated, but honestly, this is not really that
Yeah,
difficult.
it's not.
Not that much of a learning
Yeah.
curve.
So to replicate all this stuff in real software, like C, for example, it would take you a lot of time to come up with this, and it's just so much easier to get this and start start using it. The way we supply this flow is exactly what you see here in source form, and you can modify it as much as you like. Change labels, you can move things around on the dashboard. On the control panel, you can organize your dashboard into multiple screens with tabs, or put all on one, whatever you want to do. Change it to dark mode. There's all kinds of easy modifications you can make.
That's really awesome. And again, there's plenty of community support here, and to get anything done, you're gonna be able to get there pretty quickly.
Yeah.
That's
yeah, absolutely.
Awesome.
Yeah. I think the most important things about this, number one, you don't need to do any of this code stuff. You could just literally take it out of the box, plug and play, turn it on, and use it. Second thing is, if you want to enhance it, like you said, Mike, there's a very big community of smart people that are just very happy to help. A great example is Kyle AA0Z, who's got a really good YouTube channel. Kyle's done tons of talks and web streams and stuff about Node-RED. Very knowledgeable guy and part of a great community. So yeah, and if you do want to get into and go to town, and because you're like a real software guy and you really want to do fancy stuff, you can. One last thing is you can do a bunch of automation. The way we ship the dashboard it's very much a display of what the current state is, or if you actuate something, what the update is. You can also add automation. What do I mean by that? So automation is where you add additional logic to the way the Node-RED flow works. I'll give you an example. I have a user who has a repeater system, and they said, okay, look, we're in a snowy part of the world. We have a main antenna and we have a backup antenna. If the main antenna fails, we want to automatically switch to our backup antenna. Can you do that? And I said, okay, in the hardware, yeah. I mean, everything off the shelf, we can do that right now because we have a UHF, VHF coax relay and all the other stuff, and a wattmeter module, et cetera. So we can monitor the forward and reflected power on your antenna. And as far as the automatic failover, that's like 3 things in Node-RED. I mean, it's all because what you're really doing is in the control loop, you're saying, what's the reflected power? And as soon as the reflected power goes over a threshold that you set, then you have a block that says flip the relay, flip the coax relay. And by the way, send me an email that tells me I just did this. So that sort of automation on top of the base system is really simple to do and could be very, very powerful.
That's really awesome. Is there anything else you want to add before we wrap this up?
No, I think that's a good overview. Check out groups.io, look for the Node-RED Amateur Radio Forum. That's your best place to go. And thanks a lot, Mike. Appreciate the time.
Absolutely. Yeah. Node-RED.org. And also make sure you check out sierraradio.net and of course, the DX Engineering website for more information on the Sierra Radio products. George, thank you. I really appreciate it.
Thanks, Mike.
And that wraps up the second video in this series. In the next video, we'll look at the various station controller components and what it takes to get them set up and working. You can find more information on the DX Engineering and Sierra Radio websites, and I'll leave a link in the description. Thanks for watching today. I'm Michael K. Idar. We'll catch you on the next one.